Hello everyone. Let's see one more case from heavy equipment manufacturer, and this will give all of us a quick overview about CNX's automation for structural simulation process. So this is the case from heavy equipment manufacturer. So you can see here this is a dozer machine, and this front bucket and push bar, these two things make an assembly which we call it as a push beam assembly. So push beam assembly is area of interest here, and the current challenges are designers should be able to perform the dependable simulation, which in turn should reduce the simulation turnaround time significantly. Also, it should help to have a systematic simulation for all designs, and the workflow should ensure that the simulations done by designers, they are following the same standard practices which analysts are following in their tools. Also, the workflow should reliably handle the highly complex and vastly varying geometries, and the workflow should be independent of specific solver. So the current user challenges, those are overcome by CNX's workflow, and there are some advantages over the traditional process by the solution implemented by CNX's workflow. So firstly, it helps the designers to start the simulation by their own. So the process can be run 24 by 7. There's no need of any analyst getting involved in this process. So the simulation turnaround time reduces significantly. Also, there is a common end-to-end process and user interface for multiple solvers. So if somebody wants to vary the load cases or wants to change some solver specific setting, then that can be handled with the low code tools. Also, workflow ensures that simulation results are always comparable. Secondly, the automation is done through low-code tools. So CANXS and ESA, it largely avoids the scripting and programming. So maintaining and implementation of this workflow is very fast and efficient. No need to have a specific team for maintaining this workflow. In-house analysts, they are able to create and maintain the abstract models and the overall workflow. Let's have a quick overview about automated simulation process. So here you can see designer or the analyst, they'll create a simulation ready CAD models and they'll submit it to server through the graphical user interface. So at the back end, abstract model files and the CAD model will be used by a CANXS CAD to solver automation workflow, and it will generate the input deck required by the solver. So once we submit it to solver, the solver will give the required result files. Those result files will be used by CNX's report automation workflow, and with the help of some post processor, automatic simulation report will be generated. So that report towards the end will be notified to designer or the analyst via email. So this is how the overall overview of automated simulation process. Let's see the first task in CNX's automation workflow. So the designer or the CAD engineer has to create a simulation ready CAD model. So you can see here on the screen, this is a Creo CAD model prepared for the push beam assembly. So this one is bucket assembly, these are push bar, some hydraulic cylinders are modeled. So this is the geometry created or the required for the analysis is created in Creo. Along with that, you can see here some simulation classes are assigned to the CAD parts based on the physics. So you can see here solid is one of the class which is assigned to these parts, representing that we want solid modeling for those parts. Now this geometry is created considering blade at a ground position, but if somebody wants to have the different positions of blade, then one can go in tool, in parameter, and one can just change this rotating angle value based on the requirement, maybe 10 degree or 15 degree, whatever may be the practical cases. And once we set that, this geometry will get updated accordingly, and the loads corresponding to that blade position will be considered during the analysis. So similar procedure has to be done for other geometries as well. For example, if somebody is interested in the analysis of this localized assembly, then one need to create a CAD model for that and need to add the string values for the parts in that assembly. I'll quickly show you. For example, this is the localized assembly. If somebody is interested in detailed analysis of this small assembly, then one need to create a CAD model and one need to add the simulation classes based on the physics. So this is the first task, that is creation of simulation ready CAD model. So the second task is to create an abstract model file, and the analyst will create abstract model file with the help of CA Nexus preprocessor. So you can see here this is the abstract model file created by analyst for the push beam analysis. So here analyst will make use of classes to set up the physics through attribute. For example, if I open this material attribute, then you can see it is specified on the global class, and all the relevant parameters like material properties, those are specified here. Now all these inputs are in line with the solver, and analysts, they are already aware about all these inputs. They are currently providing it in the traditional process as well. I'll quickly show you one more attribute, that is solid element set. You can notice that it is specified on the solid class, and all the relevant parameters like p solid property, material type, everything is set up here. You can notice that here the analysts are specifying the physics on the classes, whereas in traditional process analysts, they are either using geometry or either using mesh to set up the physics. So this is a major difference between CA in Excel workflow and the traditional workflow. Also, abstract model file contains the attributes related to report generation. So you can see here in the displacement attribute, one can specify what are the things they want in the auto generated report, like maximum values, some contours, animation, contour view. So these parameters can be specified here. So based on this, the automated report will generate it, and that will include whatever things is specified in the abstract model file. So far we have seen that we created a CAD model required for the analysis, and we created an abstract model file for the respective analysis. Now once these two things are done, rest all processes are automatic, and during that automatic processes, the linking of your CAD model and the abstract model file takes place. So just for your information, I'll quickly show you what happens when the CAD model gets linked with the abstract model file. So you can see here On this screen, this is the simulation model where your CAD and the abstract model file, those are linked with each other. So if you see here, if I'm clicking on this solid class, then the corresponding CAD geometries on which that class was assigned, those are getting highlighted. In a similar way, if I open the attribute which we created in the abstract model file, so all these parameters of the physics will get transferred onto the respective geometry. So this is the simulation model which will happen at the back end, and this is how the linking of your abstract model file and the CAD geometry will take place in the CNXS process. Now let's see how designers can start the simulation by their own. So this is a very simple graphical user interface created for pushbeam assembly or the pushbeam analysis. So here one can select the geometry. I'll quickly upload the already created pushbeam assembly here. I'll click on upload. Once the file is uploaded, it will be shown here. You can see here CAD file has been uploaded now. It's now asking for the blade position. So at what blade position you want to analyze this push beam assembly. So whatever angle you will provide, the respective loading condition will be considered automatically. For example, let's say if I'm saying 10 degree, then you can see a loading condition corresponding to that blade angle is considered here. For this case, I'll consider blade at 0 degree, that is on the ground, and you can see now the loading condition for the 0 degree, that is when blade is at the ground position, is getting considered automatically. Here one can set the analysis type either static or modal. I'll keep static here and I'll click on submit button. Once done, this message will pop up, that is ESAP submitted successfully. This means we have submitted our job onto a server successfully. Now we'll see the status of the job. So for that we need to go in the testing tab. So here you can see the current status of the job which we submitted just now. Also one can find the status for the earlier jobs as well. Now at the back end, the linking of your CAD model and the abstract model file, it is happening automatically. After that, the input deck will be generated, that will be submitted to solver, and the results files from the solver will be further post processed, and auto generated report will be sent to user via email. So those process will take place automatically. Also you can see here from this one can see the relevant files for their job. For example, if I'm clicking here, then I can see all the files relevant to that job. Also, if somebody wants to delete the data from the server corresponding to some job, then one can do from this button or these buttons. So this is a very simple graphical user interface, and designers can start the simulation with their own. Now this will take some time to complete all processes for this job. Meanwhile, we'll just see the ESAP workflow manager which helped to design this user interface. I'll quickly go through the ESAP workflow manager.
Now this helps to design user interfaces and relevant processes based on the requirement for that application. So here one can design the user interface based on the need. So we used modular abstract model file feature to consider different load cases for the different blade positions here.
Similarly, we use simple commands under processes. For example, we used cn autorun minus prep for pre-processing. We use simple command for solving, and we also used simple command for post-processing.
So this way one can quickly customize their user interface and the relevant processes for the application through this ESAP workflow manager.
I will quickly go through the auto-generated report. Again, this report will be generated based on the setting given in abstract model file. And as I said, this report will be notified to designer or analyst through email. So you can see here, the report highlights which CAD assembly was used during analysis. After that, it shows the contents from this report, some information related to product, a quick summary of model, that is which abstract model file was used, which CAD assembly was used, what was the solver, what was the analysis type, what was the materials used and their respective properties. So those details are given in the model summary. Also the materials assigned to the CAD parts, that is also documented here. Going further, some simulation inputs like where the constraints and the loads were applied. So you can see here, these are the constraints and those are applied at these 4 locations, and their respective values are given here. That is first degree of freedom to fifth degree of freedom, those are constrained here. Similarly, related to load, the load is applied at these 5 locations and their respective values are also documented here. So you can see here component 1 and component 3, it means load is applied in the X and Z direction. Going further, a quick view about geometry. After that, a mesh view is given here, a displacement contour for the load step, a stress contour for the 3D parts, stress contour for 2D part is also given here, strain contour for overall assembly, some links for the animation. Towards the end you will see the simulation outputs, that is what are the maximum displacement stress strain values came after doing the analysis of push beam assembly. So again, this is just a sample report and it can be customized based on the requirement. So customer's report will be more comprehensive. This is just a sample report which is shown for the demo purpose. I'll quickly go through the implementation efforts. So the CAD model which we created, we added some classes on those parts, so that we call it as a tagging. So it took 15 to 20 minutes for that. Again, for next design proposal, that time would be lesser than this because we will be just updating our CAD models. Secondly, for abstract model file, it took 35 minutes. Now this is the one-time role which analyst has to do. For all other design proposals, analyst is not going to spend any time on abstract model file creation. For GUI configuration and workflow configuration, it took around one day each. So overall, the implementation efforts were 4 to 5 days work.